Yeah,
Yeah.
I actually
Okay.
just so now we are officially live. So
Oh, okay.
I always like to start off the live stream with, "Are we live? Yeah, we're live." Um,
Okay. Good
so
to know.
so now we're officially live. So at least um, so in that case, we haven't hit. I'll say this much: we haven't hit 100 people, but if we did hit 100 people, they will overflow into the YouTube stream. So congratulations for everybody who got in before we hit 100 people.
Yeah.
I've never had to plan for that before, so this was a fun one. Uh, I don't pay for the super expensive tier of Zoom. All right, so we're coming in. Just have on the for now, like while we're in the chat, like feel free to like put in the chat where are you from, what brings you here, maybe what you're excited about learning. Um, because this is a virtual session, so not yeah, everybody actually is going to be from Orlando, and that's why I do like to see, where people are from when we kind of open up beyond the Orlando reach. And if you don't want to, we can also, there's enough people right now, you can come off mute and talk if you wanted to. Like, this is the forced networking moment. We don't get the networking in person, so it's like this forced awkward moment.
So we have Ariwa, am I pronouncing it right? From Miami, Florida. Hello.
Yeah, hi. Fort Myers. Awesome. That's my home stomping ground before I moved to Orlando. I went to FGCU for my undergraduate. When they got popular for their basketball. Like faded immediately, like popularity only for a year.
Hello, Chris.
Welcome from Tallahassee. See, I like it when we expand outside of Orlando, isn't it? It's, it gets a lot more opportunities to learn.
Yeah.
Because most of all, like the most important thing is that we give opportunities to learn. And that you guys got to deal with now my soapbox moment here. But I guess really like let's kicking it off, getting close to like we're getting close to 6:05. And so I did say we'll start a few minutes after. Um, for those of you that maybe aren't aware of like Orlando AWS user group, obviously the Orlando AWS user group is based in Orlando, Florida. Every once in a while we do virtual meetups, and we try for the most part to do hybrid meetups as well to give that opportunity for people to learn because um, not always is education opportunities like really accessible for everybody. So we will try one way to make it accessible. It's not that we're going to solve every single solution, right? Um, but giving things more open to people, giving more of those opportunities to join in, that's what's really, really important. And it helps grow our community, especially the AWS community. When we have so many new things coming out every single day, especially like at this point, we're looking at AI coming out, something brand new every single time, some new model. It's hard to keep track of it all. So these opportunities is what grows us. And we're really lucky here because we have Mohammed who is going to talk to us about building generative AI using Amazon Bedrock. And this is, at least he told me, so I'm going to trust him very much, a very practical introduction to really get you started. So, really, beyond that, I'm going to stop talking. I'm going to hand it over to Mohammed.
All right. Thank you. Let me first share my screen here. Yes, hello everyone. Thank you so much, Joanne, for this intro. It's Mohammed Sharaf here. I'm a senior solutions architect with Amazon AWS. I've been in there for 4 years now, and I've been doing a lot of solutions and related to migration and modernization. And then now, everybody is about GenAI and how we can use these, and we are all learning. And you are right. Every day there is a new thing. So you start with LLMs some time ago, and we have more and more APIs and stuff to learn, and MCPs and whatnot. So I thought today to be here with you. I'm actually based in Dallas, Texas, and I wanted really to dive into how to build practical GenAI applications using Amazon Bedrock. Amazon Bedrock is the flagship service that AWS is providing for GenAI. So I wanted to follow a use case and then learn some Bedrock features, build a live demo from scratch. So we're gonna jump into the console and the Visual Studio Code and write some code and stuff. And then this is gonna be like really like a practical session. This is very foundational, so you're not expected to be an expert in GenAI or any of these. I'm gonna be talking about the foundations and basics, but I wanted to make sure that I show you an end-to-end solution at the end of the day. So you come out of this 1 hour with something to see the whole picture, and then it opens up for you to learn more, or maybe we can have more discussions or sessions or whatnot. So while presenting, I don't see the chat, so either you speak up or maybe write the questions in the chat, and then in the end, we're going to have a QA session to cover everything. So let me frame today's journey with a story. So let's meet Sarah here. So Sarah is a developer. She's been tasked to build a chatbot for internal support. So they have an IT department. They want to use GenAI to build a support application. So her goal here is to create a simple interface that responds to employee questions using AI. And she never worked with LLM before, so infrastructure is not her thing. But she heard of this Amazon Bedrock and wants to try it, and that's what we are going to discuss today. So our solution today, our demo will be what she would typically do. I just want to go off camera here so I can give you more real estate. So as you see here, we're gonna start by an introduction to Bedrock, the models, the large language models or foundation models it supports. We'll look at key features briefly, then I'm gonna jump into the live walkthrough. I'm gonna start with the Bedrock console, show you the different important features in there. Then we're gonna write some code to make calls to Bedrock, and then deploy on API Gateway and Lambda. So that's my plan here. But first things first, what is Amazon Bedrock? So Amazon Bedrock is really like a service that provides you uh, access to different foundation models like Claude, Titan, Cohere, and others, a lot of other models via a simple API. So think of it as the layer, the API layer that enables you to have access to multitude of large language models available from Amazon and from partners and from third party via this standard API. When you use Bedrock to have access to these, you don't need to manage any infrastructure. So it's following the serverless notion. You just choose a model and then you start prompting and then you get the responses back. So Amazon Bedrock really gives you different features or components that you need beyond just a model to use. First, it provides you with high-performing foundation models from leading companies. So you will notice when we go over, we have many models available from Amazon, and we have several partners with models available. And then there is the marketplace where any third party can also include their models to be used in there. You can also add your own custom model in cases of organizations that build their own models. When you use Bedrock, you can scale cost effectively with the selection of different consumption models. And I'm going to talk to you by the end of today on the consumption models and how you calculate price of usage, because it's very important to understand this even as a developer, that um, you might make decisions on using specific APIs based on pricing as well. So you want to understand that. Using contextual information from your company's private data sources is important to deliver more relevant, accurate, and customized responses. And here we're talking about RAG and how you can use it. And I'm going to talk about this briefly today. It's the RAG is a topic of its own. We can spend an hour or more to talk about it. I'm going to talk briefly today about it, and we will see if there is traction in there to expand later on. And of course, very important to implement safeguards customized to the application requirements. Responsible AI policy is very important topic today. And then the last point here is connecting with company systems APIs, so standard APIs. So when you look at all these, the Bedrock provides this to you out of the box and enables you to use it, to utilize it, to provide these models and build applications on top of that. So you will notice it's really like important to have this framework and these different features when you are building an organizational or a corporate type of solution. But if you look at the diagram on the top of the screen here, it's still very straightforward. If you are familiar with the very famous ChatGPT, you send a prompt, and then there is a model that processes this prompt, understand it, run its algorithm, generate an output, and sends it back to you. And that's exactly what Bedrock will provide to you. So you use the service through its APIs, you select a model, you send a prompt to that model via Bedrock, via its API or SDK, or even the command line interface, if you will, and then you get the output. And that's what we're going to see today. Before going further, I wanted to make sure we understand what is a model. We keep saying the foundation model, and this diagram here is showing you an example of several models that are available today on Bedrock. You might be familiar with some of these names. A model or a foundation model are really like large artificial intelligence model. They are trained on massive data sets. So they have algorithm or more that get trained using a lot of data sets, and that renders them capable of performing a wide range of tasks. So that's how when you send the prompts, they can send the responses back to you. So when you look at how this works, the first thing is data gathering. So a large and diverse data set is compiled from various sources. And that's how these large language models are being built. And then a suitable neural network algorithm is chosen for transformation or diffusion models. So a lot of ML details in here, we are not going to go there, but you have an algorithm that runs on this set of data, but then you need to do training of these models. So you train the models on massive data sets using different approaches, supervised learning, and others. But then you need to adapt this pre-trained model to specific tasks. So you can do fine-tuning, prompting. The way you do it today, if you are using any of these, you send a prompt and then you start tuning the prompt, adding something, putting some guidelines for the model to understand or to give you your response, or going beyond that into fine-tuning and RAG. And I'm going to talk about RAG in a second. So one of the most important features of Bedrock is how easy it is to experiment with these models. We select the models, combine a wide range of foundation models in your application, and build on top of these. So again, for our case today, so our friend Sarah here learns about the available models, and she's gonna use Titan because it's scalable. She sees Claude is also good for reasoning. Mistral is fast, so Cohere works well for embeddings. And we are gonna today select the Titan Text Express because it's fast, it's easy, and I think it's also one of the less costly ones. And we're going to use it for the app that Sarah is going to be building, right? So let me start with an overview of some of the features that Bedrock provides. The first thing is the foundation model's choice. When you use Bedrock, you have four major features. So a set of leading models from top providers, as I mentioned. You can actually do model evaluation. So there is evaluation tools that help you select the right model to decide on the use case that you have. You can import your own models, as I mentioned, and of course, if there is a third party that has the model in marketplace, you can still import it and use this one. What you see here is an important aspect, and we are going to use it today in our demo or in our application we're going to be building. When you use any of the models, you can control the behavior of this model or change the behavior of this model to be more precise using some configurations called inference parameters. So the diagram that you see or the snapshot that you see is actually from the Bedrock console, and it's showing you here the playground. And the playground is just like a simple interface so you can test a model or send a prompt and get a response back. But then to the left here, you will see several inference parameters that control or change the behavior. So the first set here, so on the top left, you see I'm selecting one of the models, the Nova Pro, that's an Amazon model. Then I can change the randomness and diversity configuration. So temperature controls the randomness in the word choice. So when you like have a lower temperature, it varies from 0 to 1, by the way. If it's 0, then the model is not gonna be like, will be the least randomness. So it's gonna be very strict to the word choice. So if you wanted, it's more predictable, to be specific. If you want this model to respond to be more creative, then you add the temperature or increase the temperature to 1. So now we are seeing randomness in the responses. Also, the top P is similar. Usually, when you are testing and trying things, you will start by changing only one parameter, and then you see how the response is in order to identify where you want to go with your parameters or with the changes in here. Another important configuration is the length of the response. You can control the response size, the size of the response coming back to you from the model via Bedrock, and you can also add a stop sequence. So a stop sequence is a set of characters that is going to make the model stop producing once it produces this set of sequence. So let's say that you put a specific word here, like the word hardware, and then you ask a question, and then once the response is bringing up the word hardware, it's going to stop instantly. So this is another way to control the length of your responses, and this is really like related to cost or related to the requirements for your application. Maybe your application is only looking for a specific uh, uh, length of response that you want to have. Okay, so let's go here, and really before we jump into the code and the demo, it's important to understand how Amazon Bedrock works under the hood. So Amazon Bedrock is following the same model that other services that we have on AWS follow. So there is an API at the core. On top of this API, there are one or more SDKs, and then you can even use these, or you can actually use the CLI. So when you install the AWS client on your machine, your local machine, you can still use it. So again, as I mentioned here, we are going to use the SDK, the Python SDK today. It's called the Boto3, and this is the library that enables you to access AWS services via Python. And we're going to use this. So before going there, I wanted to show you these different snippets to understand where we're going. So the first one on the top left, we use the Bedrock client to list the available foundation models. So if you wanted to manage the actually to manage Bedrock itself, list its models, or query stuff related to Bedrock itself, you use the Bedrock client. Then when it's time to generate content, actually, you switch to the Bedrock runtime client. That's why you see here, I don't know if you see my cursor, but you see here we are using Bedrock, but down there we are using the Bedrock runtime because this is a code snippet that will produce a response or send the prompt and get the response back to you. And then you use the invoke model here from this Bedrock runtime client, and the invoke model sends a prompt and waits for a full response. A different one here is invoke model with response stream, and this is very similar to what you maybe experience when you send to, I don't know, ChatGPT or similar. You send the prompt and then you start getting the responses one line at a time, or one chunk at a time, or one paragraph at a time. So that's the difference between this method and the invoke model method. And then finally, there is the converse API, and this simplifies the multi-turn conversation. So gives context to the conversation, and then you pass in a message list and configuration options, and it handles the rest. So as you see here, we have multiple methods or functions that you can use with the Bedrock runtime client, and you decide how you want to use them based on the application that you are building. So today I'm going to use the invoke model to build the application, but I wanted you to know that these are also available for you. And as I mentioned, the RAG is a topic of its own. We can speak a lot about it, but I wanted to just let you know that there is a feature in Bedrock called knowledge bases, and this is an implementation of RAG. So it gives you this out of the box. So this is one of the most popular design patterns for generative AI applications that need to reason over your enterprise data. So like if you have documents, emails, or product manuals, RAG, or retrieval augmented generation, works by pulling in the relevant content from a vector database that has your data and adds this to the prompt. So this content is added as a context and passed along to the model. So instead of just guessing, the model will respond with this context or this data that you own or that you have. So it's giving your model a real-time memory, one that's constantly updated. All what you need to do is add more of your data or files or documents or emails, and then the model now is going to use these to set the context and send you relevant responses. Amazon Bedrock implements the RAG through the knowledge base feature. With just like a few clicks, you connect Bedrock to a data source, like maybe an S3 bucket, and it will automatically extract the content, index it, and then embed it using an embedding model. So Cohere or Titan are they have embedding models that is used to build these vectors into the vector store. The store is the vector store here supported by Bedrock is OpenSearch or Pinecone. And then when you send a query to the model, the knowledge base retrieves the most relevant chunks, injects them into the context, and passes the expanded prompt to the foundation model. So again, we can go over this in a separate context, but today I wanted to focus on the basic usage here. So this is the architecture for the chatbot that Sarah is gonna be building, or that we are gonna be building for her. So it's gonna follow like this simple structure. So user will send a question to API Gateway endpoint. This will trigger a Lambda function. Inside the Lambda function, we're going to use Python code and Boto3 to invoke the model, the Titan model in this case. Titan Text Express is the one we're going to use. and the model on Bedrock, and it will return the answer, and then we take the answer back to the client. So straightforward, but end-to-end, building the web application or the web interface, if you will, to use this model. So let's start the live demo. I'm going to start by going through a console tour. Then we're going to write the code. I'm going to show you the code on Visual Studio Code with Moto 3. And then once we have this code, we're going to take it into Lambda. We're going to build the Lambda function and the API gateway for it. So let me go out of this here. Just having here. If you see my console, can you just confirm that you see the browser?
Yes, we see it. Thank you.
Excellent, excellent. So I'm going to start here, as I mentioned, with a walkthrough of the console. So standard Amazon Bedrock service here. You go there and then you see the menu to your left. When you look at the very bottom of the menu here, the first step you need to do when you start doing or using Amazon Bedrock is to go to the Bedrock configurations and model access. By default, you will see a lot of models. And when you start the first time, all of them will be like having this gray status available to request. They are not granted yet. All you need to do is to select the models. So you modify the model access in here, select the models that are not selected yet, and request the access. Once you do this, then it's going to change to the status of granted. So as you see here, it's going to be all access granted. So you can do like I did here. I just like requested all of them and they all got granted, or you can just select the ones that you are going to use. You will notice here these models are already available on AWS, so they are not so you don't need to import them, you don't need to bring them from the marketplace. So you'll see like AI 21 Labs they have like 3 of these. Amazon is providing 2 sets of models, the Titan family and the Nova, the newer Nova family. The Claude ones, and this is the latest ones, the Claude Opus 4 and Sonnet, and were just released. And that's why you see I did not even request them yet, but you will see also Cohere here and DeepSeek and others. So your first step is to go down to the model access and enable or request the access for your models that you're gonna use. Then we go on the very top, the model catalog. The model catalog is a very important one for you when you develop applications. Here in this catalog, you can search for the specific model that you decide to use. So let's say I'm gonna filter by Amazon models only, and I'm gonna look at any one of them. Let's say Nova Pro. When you click on a specific model, you will notice it gives you information about it, an overview and who's providing it and whatnot. But there is 2 important technical pieces of information here. The first one is the model ID. The model ID is the identifier for this model. So when you make an API call, when you make an SDK call, you need to identify the model ID in the exact way it is. So if we decide to use this model, I need to copy the model ID and use this one the way it is. Another piece of information here is the API request. So each model will have a JSON file here that shows you how you can formulate the request that you send to the model. So the model ID, the content type, and in the body, the inference configuration. So again, the same inference parameters that we discussed, but then the format for messages and how you can send them. So each model can have a different type. So if I look at a different one, let's say Anthropic, Claude, let's see any one of these, you will still have the same. So model ID is different now. We need to copy this, and then you will notice that this is different because this one, I think I selected, yeah, the Sonnet one. It can take a source type of image and then you provide the media type or text and so on. So each one of these. So it's very important because today when you look at how you write the code to make the call, we're going to use the API requests, the format in here. So this is an important feature here that you will need when you start building. Now, another important one here is the playgrounds. So if you look at the playgrounds, as I mentioned before, playgrounds gives you they give you a simple interface to try this model. So first, you're gonna select whether you're gonna do a chat or single prompt, and then you select a model. So when you go here and select a model, let's say I'm gonna use the Amazon, and then I'm gonna use Titan Text Express, and then I apply. So now I selected the model I want to test. You notice here the randomness and diversity, the length, and all this stuff that we discussed a little while ago. And then you can add you can add a prompt here. So I'm gonna just write any prompt here. So what are the main 5 topics to search for when troubleshooting Wi-Fi connectivity? I just selected this to be having the same theme that our friend Sarah is using. So I'm gonna run here, and you will notice that it's gonna send you responses that are coming from the model. So again, what you can do here, you will notice, of course, that this one is sending you like concise single line responses. Maybe if we change the model to Nova or even other ones like Cohere, it might have a different type of response, but that's where you can test and try and see the different models. So again, you get to use the models in here, you test it, you also you can do the image and video and whatnot. We can do some change here in this temperature. Let's say that we change it from 0 to 1, and then we send this again. I really don't know if it's gonna make a big difference or not. Let's see. Yeah, so now it's because we added this, so it's gonna give you some, I think, different type of responses or not, or adding some more. So again, when you start you testing the models, you usually get some different prompts that you prepare them, and then you try different things. You try different models on the same prompt. You try different parameters until you like come up with what you really need to select and choose. And then you are going to take these configurations into your actual code in order to set it up when you are sending the calls. So okay, so that's how we see here the Bedrock. Now I'm going to start by building the application, but before going there, we need to do some security stuff. So I'm going to go to the IAM. I need in my application, I will need to build Lambda function, and the Lambda function is going to call Bedrock. In order to do this, I want to make sure that I have a role that I provide to the Lambda function, so it has I grant the access for it to access Bedrock. And in order to have this role, I need to create a policy to attach it to the role. So I'm going to start with the policy in here. I'm going to create policy, and I'm going to do the JSON here, and I'm going to change this policy here. So if you look at the policy I just pasted in here, this policy is allowing the Bedrock full access. So any service that's going to have this policy attached to it is going to have full access to Bedrock. It can use any of the services available or any of the API calls available. In real life, you might change this a little or make sure that you have the needed access for specific services or different services. But for the purpose of today and for our demo, I don't want to spend time troubleshooting access. So I'm going to give it the full access, and I'm going to allow it, and I'm going to save it here. So I'm going to give it a name. So let's say I'm going to call it demo policy and create the policy. Now I have the policy in place. The next step is I'm going to create a role, and this role I'm going to use a role for Lambda. So for my Lambda function in here, I'm gonna also attach this role that we just created, the demo policy in here. So I'm attaching the policy to the role, and I'm gonna call it demo role. And I'm gonna create the role. Now I have the role ready. So later on here, demo role down here. So later on, when we build the Lambda function, we need to attach this demo role too. Excellent. So our next step is really to build the application. So I have Visual Studio Code in here. You can use your preferred IDE. You can even use your VI if you are doing this, or any of these. I prepared this environment beforehand, so in order not to again spend time building or adding the different libraries. But for example, you need to at least make sure that you have installed the Boto 3. So here I'm gonna get the terminal, and in the terminal here, I'm gonna just install Boto 3. Of course, it's gonna tell you that it's already satisfied because I installed it from before, but that's the first step you need to do. Make sure that you install this. In my environment, I have them all installed in here. I'm going to create a new file. So new file here, I'm gonna call it demo.py. And here, in this file, I'm gonna start by writing my code to make the call to Bedrock. So if you look here, I started by importing the Boto 3 and the JSON. I'm gonna be using that, and I'm gonna set the region. So you have each of these models that we have been discussing is available on several regions. So you need to define which region you are making the call to. Then I'm gonna initialize the Bedrock runtime client. So here, as you see, the client is Bedrock runtime, and I am providing the region. Then my next step here is to define the model ID. So here again, I copied the Titan Express V1. So I copied the model ID from the catalog, as we have seen a little while ago, and I'm pasting it in here so we can use it. And I also create just like a variable that holds my prompt. So provide the top 5 steps to troubleshoot Wi-Fi connectivity. So just preparing all the required attributes to make the call. And then the next step here is to build the configuration parameters, so the inference parameters. The same parameters that we have seen there. So maybe maximum token counts is, I'm gonna put it at 124, and I'm gonna put this at 0.1 maybe. So you can add, as you notice here, you add all these as a JSON text, and then we convert this using the dump s into an actual JSON payload. And that's what we are going to send to our client. Then the last section here is actually making the call. So invoking the model here, I'm gonna get the response, and I'm gonna invoke the model, pass in the model ID, the request payload, which in the body. Content type, I'm defining that this content we are sending is gonna be a JSON, and the response body here is gonna get the response and extracts the body section and turns it into the text in the response body. And here we are extracting this into text and printing this out. So that's how we have the application here making the call. And let's run. Okay, I need to just select an environment. Okay. let's run this here. Let me just make this a little bit bigger here so you can see. So as you notice here, what happened is when I run this one here in the terminal, it produces the generated text and gives you the list down here into the console. So this is showing us that simple invoke model made it through into Bedrock because we selected the different parameters up here and it's giving you the response back. You can definitely do many things in here. You can change the configuration. Let's say that we are putting this into 256 only and we rerun it again. And this should actually, if we look at the code in here, it takes a couple of seconds to produce because we are using the invoke model, which means it's gonna prepare the whole answer and then the whole response and then send it all together. And you notice here one thing, because I changed the maximum size, it truncated the response at like in the middle of a sentence or something. So it stops at a specific size. So because the maximum tokens is reached. By the way, when we look at the inputs and outputs of a model, the token is about 3/4 of a word. So any word, any English word that you send in here, the average English word takes about 1.5 tokens or 1.25 tokens. And all the models are calculating the inferences and the inputs and prompts and inferences into tokens, which are, as I mentioned, 3/4 of a word. So here we are defining that we only expect the maximum token count for the response to be 256. That's why it truncated the response in here. All right. Let's say that we want to use a different approach rather than using the invoke model. I want to use the invoke model with the invoke model. Give me a second. So let's say that we want to use the invoke model with response stream. So I'm going to create a new file in here. And I'm going to, let me just paste the code in here. So this one here is very similar to the first one. So we use the same runtime, the same model ID and whatnot, but I made a different call to a different from the client invoke model with response stream, and I provided the responses or the parameters in here, the configuration in here. So I'm gonna run, and again running the same type of prompt. Let me just save it, file, let's say demo2, and let me run this in here. So we're gonna clear first in order to see the response, and I'm gonna run it in here, and let's see. You will notice here the responses are coming to you in chunks. So each chunk is its own JSON chunk and sending you the responses in these chunks. So again, giving you faster response and sending these to you, very similar to what you are used to from using like ChatGPT or any of the other models. So again, it depends on your application, how you, if you're building a chatbot, you can use this, you can use Converse. If on the contrary, you are maybe retrieving a list of some specific data, you can just do the other one here and make the call using the invoke model all of a sudden. So again, that's how it is. Now that we have the code, we have everything in place, let's build the Lambda function. So I'm gonna go back to my interface in here, and let me just sign in again because I got signed out from my account. in here, what we're going to do now is build the Lambda function. So I'm going to go to Lambda, and you will notice one thing here. Bedrock is totally seamless integrated with the other services in here. So the Lambda function can make the call directly, as you're going to see. So when you use Bedrock while building an application like using serverless services on AWS, it's going to be a very straightforward approach. So I'm going to select the function. I'm going to give the function a name. So demo Lambda function, or maybe demo Lambda Bedrock function. And for the runtime, I'm going to do Python 3. And here, I'm going to change the role. That's the point where I wanted to use demo role. If I didn't do it, when we run it, it's not going to have access and it's going to give us an error. So make sure that you select a role that provides access to this Lambda function to access Bedrock. And we create the function in here. So once we have the function created, I'm going to write the code in here, the same code or very similar to what we just did on the Visual Studio. I'm just going to tweak it here to use the Lambda handler here. So the framework that Lambda uses. So in Lambda, you need to have the function with the handler name here so it can process it. And of course, we are going to pass the prompt as a parameter. So as you see here, the code here is getting the parameter, and we're going to call it prompt. So it's going to extract it from the event that is sent to Lambda, and it's going to extract the prompt, and then takes this prompt and process it or passes it through to Bedrock. So again, the response body here and the invoke model is set up the same way that we did, and some exceptions. So the same thing, we are just difference here is I'm passing this prompt to the Lambda function. So I'm going to deploy, and the code is now deployed. Before we make the call from API Gateway, I wanted to test this thing here. One thing you need to look at even before testing is the configuration. In the configuration, you will notice that the timeout, standard timeout settings for a Lambda function is 3 seconds. We might need more time because we are waiting for Bedrock to build its response and sends it back all as one chunk. So I'm going to edit this and increase the timeout to 1. So if you are going to follow this demo later or try it, make sure that you increase the timeout in here. You can just try it. If it gives you like a timeout error exception, then you can get it from the configuration in here. All right, so I'm gonna go back to the code, to the test tab in here. In the test tab, I'm gonna create a new test to create a new event here, and I'm going to send the prompt as the event JSON. So I'm gonna send the same prompt that we're using in the event JSON, and I'm gonna call it demo test, and I'm gonna save it. And now I have this saved in place. I'm gonna go back to the code and click on test. And you notice that now it's running in here. I'm gonna just expand it so you can see. And in a moment, it's going to send the responses back. As you see here, let me just expand it up here. As you see, the response after some time, status is succeeded, and it's sending us the body as the response that we expected. So now we have the Lambda function and it's tested. The next step is to build the API gateway and connect it to the Lambda function. So I'm going to go to API gateway here, and I'm going to create an API. I'm gonna use REST API. So that's the one I'm gonna select here, and I'm gonna give a name here. So let's say demo API Bedrock, and I'm going to just create the API. And then I'm gonna create a resource, and the resource name, I'm gonna call it, let's say, Bedrock, or resource name Bedrock, and create a resource. I have the resource in here, and I'm gonna create a method. In the method here, I'm going to use a post method, and I'm gonna integrate it with Lambda function. So selecting Lambda function in here, I'm gonna choose the Lambda function that we just created. So demo Lambda Bedrock function. So now it's connected, and we create the method. So as you see, it's created for us in here, and it's giving us uh, uh, the, the API. So I'm gonna deploy the API as a new stage. I'm gonna call it stage 1. So that's just deploying this endpoint. And you will notice that now I have the invoke URL for this endpoint. I'm going to copy this because I'm going to use it to invoke. And my next step is to make a call in here. I'm gonna try now to do it through the terminal for a change. So I'm gonna open my terminal in here. Of course, my local machine has been configured to connect to my account. So that's one step you need to do. If you have not, then you need to have the AWS CLI or the AWS client configured in your machine. In our case here, I'm going to use the curl, and I just added here, as you, if you compare it, the same URL. So make a call to the URL /stage1/bedrock. And then I'm going to provide a different prompt, like list 10 lessons from the book, how to sell anything to anybody. So a different prompt in here, and I'm going to run it. And this should make the call to API Gateway, pass it through to the Lambda function, goes to Bedrock, get the answer, and bring it back to us on the screen in here in a second or two. So as you see here, I made a call to the API Gateway, and it responded back with the response from Bedrock. I just wanted to add one more thing. So I wanted for our friend Sarah to have a simple interface. So I used a framework called Streamlit. I don't know if anyone is familiar with, but Streamlit gives you a very easy way to build web applications using Python, and it's usually used for testing or to build simple interfaces. So I'm going to use the same in here. I'm going to have a new file, call it streamlit.py, and in there I'm going to copy my code in here. Let me just take this down and show you what it is. So here I just import the Streamlit library requests in JSON, and Streamlit is giving you a lot of good features to add, like a web page title and uh, like a lot of presentation made easy with Streamlit. In our case here, I have the API URL that I'm going to call. So I want to change this one here with the URL that I'm using for my API gateway. So I'm going to do copy, and I'm going to paste the exact one that we are using. So this is our gateway URL and stage 1 that we deployed, and the name of the method that calls the Lambda function in here. And then again, we have a prompt here, text area, so we can add the prompt. So when we use it on runtime, and we are adding a button to send the request, and it's gonna send this request to the post in here. So we request the post, and then it's going to send the URL, send the JSON body and the headers, and get the responses and print the responses on the screen. I'm going to save this one here, and this one runs in a different way. So I'm going to run it using Streamlit run, and I'm going to call the file Streamlit PY. And when you do this, it's going to give you, it runs and gives you like a simple web interface here that got rendered by Streamlit. And the endpoint here is the one that we have. We can change it if you maybe do a stage 2 and you deploy a second stage, you can just change it in here and enter your prompt, and we can add any of the prompts that we have, or we can write something different here. How to fix a printer that is not working on a MacBook Pro. And then I send the request, and you will notice that it's going to be running in here, and in a second it's going to build the response down there. So the response status, and it's giving you the same response on the page. The first step is to check if the printer is turned on, and so on and so forth. Of course, this is very like simple, bare minimum development. If you are building this for real, you will extract this JSON and massage the data and put it in a pleasant way to be displayed and whatnot. But I really added this part so we can get an end-to-end within our time here to build the whole thing. So as you see here, we started by selecting the model. We build the Lambda function, and now the API gateway, and we have an interface for it. I hope this demo was giving you some ideas of what you can do with this and how easy it is. If we can do it here in like less than 30 minutes, then probably it's going to be very much productive for you when you are building a real application. So now that we are done with the live demo, I just wanted to go over some other aspects. Remember when I discussed the cost and scaling in the beginning, I said that, yeah, cost is important. When you look at any of these models, when you use them, the way the cost is calculated is not the typical way. So if you were using RDS or EC2, if you are familiar with how they calculate the cost, it's based on time. So the more time you use a service, the more like you pay for by the unit time for it. When you use Bedrock and when you use the models, you are paying for the tokens, the input and the output tokens. So in other words, the more prompts you send and the more responses you get, the more number of words that are produced. That's what makes the cost for you. So you want to understand when you are selecting a model and the size of the responses, you want to make sure that you are selecting these to fit the use case that you are building for. Make sure that if you are requiring like a couple of words as a response for your application, you use a model and you confine the responses to what you need, and make sure that you calculate this in a proper way. Another thing is to know that the foundation models are available in multiple regions, and each foundation model will have a threshold to be capped within your account. So it's going to be throttled after that. It's not like a small threshold, but in some cases, when you are building a production environment and it's used by a lot of users, you want to scale and you want to avoid this throttling. So what you can do here is really like use multiple models from multiple regions. So you have the model running on each region. You can create what we call an inference profile. Inference profile here is just like a container that includes the foundation model and multiple foundation models across different regions. And when you send the requests or the prompts as input tokens, as you see on the diagram, it's going to be sent to the multiple regions, running across all of them, and then bringing back the responses to you. So this way you can really scale across regions and make sure that you are avoiding the throttling. And before we end, it's important to speak about security. So security essentials, a lot of features for security is provided by Bedrock. So it supports IAM policies, as you have seen today, for fine-grained access. All traffic is encrypted, and you can integrate with KMS. And so if you have like sensitive workloads in any regulated environments, this is a service that is really like suitable for that. It provides comprehensive data protection privacy. So the data that's used by Bedrock is never used for service improvement. Nobody at AWS will have access to this. It's not shared with any third party. So I just want to make sure that I mention this here. You can even use private links. So if you are having a solution built on AWS, you don't want to use the public endpoints of the service. You can create private links, and all traffic goes through the VPC. It does not go over the internet at all. So again, that's also available, and you can do this. All the data that you send is encrypted in transit and at rest. So a lot of features in here. And again, Bedrock is integrated with CloudWatch and CloudTrail. So monitoring and logging capabilities and tools you can use to address the governance and audit requirements. So we can use CloudWatch to track the metrics and build customized dashboards, if you will, similar to many other services, of course. And again, for application and security, so IAM enables you to control the access to your customized foundation models if you have, and you can allow or deny access to specific foundation models. So it goes to the level of who of your users is able to use specific models or not. So it's really very fine-grained. So we are at, I think, past the top of the hour, and I hope this was useful for you. Before we go, I wanted to share with you some resources in here. First, I have like the Bedrock Developer Guide. It's your go-to place to learn more. I also included a link to a hands-on workshop. This is part of the immersion days that we usually provide at Amazon AWS to our customers, but it's publicly available. So you really can click on the Bedrock hands-on workshop and follow the steps. It's gonna be much detailed. You're gonna do stuff like what we did today and more. So if you are interested to learn more, this is a good place to start. And I really encourage you to go through this workshop. Uh, and then there is the pricing page, because we talked about pricing. I wanted you to learn about pricing. And of course, the last one here is GitHub samples. You will see many code examples using Python, knowledge bases, agents, and more. I included all these in this QR code. So this QR code takes you to my link profile. If you go there and scroll to the very end, you will see all these resources. You can use them to learn about this. So next steps, I would encourage you to start in your accounts, explore Bedrock, the playground, as we have seen today. Try the models first, and then maybe build a RAG solution, or even follow the workshop that is provided in here. It's amazing what you can do with these services, and follow the AWS blogs, because we are producing these like now, like a lot of them every day. You will see a new blog post that's talking about a new technology, MCP and RAG and many other things. So really a good place to follow. So with that, I think we are at the end of this session. But let's see if you have any questions. If you want to open up for any
One
questions.
question was around the security configuration for the API.
Okay.
And then, of course, if there's other questions, feel free to, you can raise your hand if you want to ask the question, or type it in the chat.
Yeah, let me just click on the chat here so I can see it. Okay. Some security will be discussed after the live demo, but no, that's your response. Okay.
Find
So
it.
where is the question?
Did I miss the security configuration of the API?
No, so for the API gateway, we had the the public endpoint as a REST service, and it made a call directly to the Lambda function. What we needed to add is to give the Lambda function the role required to access Bedrock. But from the API gateway, it was like a publicly available endpoint. Yeah, any other questions?
What do you maybe suggest for people who are just getting started for learning for like this was a good practical. Is there any other practical hands-on workshops that you
Of
suggest?
course. So the one that's shared on the screen, I don't know, do you still see the screen or not?
Yes.
Yeah. So if you go there and look at this one, the hands-on workshop, it has many sections. So this is a starting point that you can do, and then go back to the developer guide, and it has some more tutorials. But then the one that has a lot is the Bedrock GitHub samples. So these are community built. So it's not only AWS. So you'll see a lot of these that you can use as well. But the really like if you wanted to start today, you can do the Bedrock hands-on workshop. So can you explain about Streamlit and its uses? Okay, so Streamlit is not really the focus. I used it because for me it was an easy way to give you a web interface. But if you look at their website, it provides you with an easy framework to build web applications using Python. When people build web applications, they usually go through JavaScript or REST or different other frameworks for UI, right? Python is usually not used specifically for UI or web interfaces, but Streamlit is providing this as a way to build fast and easy interfaces when you are building maybe stuff like that, testing or building very quick interface. So when you look at Streamlit and you look at its documentation, it gives you a set of method calls that builds the web interface for you. So the HTML, the title, the different components. Even when if you want to render a table, it renders for you easily. So usually it's used to build a UI on top of some Python application that you are building, or whether for machine learning or for analytics, or even just for a simple thing that what we have seen today. So again, you can, and there is a ton of resources that you can use to to learn Streamlit. What else do we have? Are there other questions or anyone?
They answered one around API load balance in the gateway, but
Yeah. Okay.
yes, William.
Yep, yeah, I just have a question about the token count parameters when you were sending the request to Bedrock earlier,
Yes.
so that when you reduce the max token count,
Yes.
the response that you get doesn't necessarily make sense. It just gets truncated, as you mentioned.
That's true.
So is there a way to have the response still make sense, as you reduce the token?
Right. Right. So there are two aspects here. The first one is like the when you set the maximum count, this is like a hard truncation, like it's not going to be more than that.
Okay.
But then what you can do is via prompting, you can tell the model how to respond back. So you can tell the model to respond about the topic and just respond in one sentence, or make a concise response, which will take your response down. So it's twofold here. The way that you control via prompting is one, but then as you are building an application for an enterprise, you want to have these guidelines in here, and you can increase it as well. So maybe you can, if let's say that your users are always sending prompts that get responses that get truncated because that's what they need, then now you are seeing the need for that, and then you change the response. And you can do this dynamically, as you have seen today from your code and your calls. So you can have these parameters dynamically set at some time, if you will. That would help.
Yep, that makes a lot of sense. Thank you.
Okay, there is a good question here. I'm new to this, but why do the requests has to go through Lambda? Why not directly to Bedrock? Okay, we are talking here about a solution. What you have seen today is a solution that is typically used to scale an application. So let's say that you are using this and you are building an application. The application has multiple components, and these components talk to each other and make requests and responses and whatnot. The place where you build all your business logic, the middle tier, or the if I can call it this way, from a previous life, that would be the place where you add your business logic. So typically, you would have multiple layers, a layer that does some business logic that calls another layer in the Lambda function. And then eventually, the Lambda function that is responsible for making the calls to Bedrock will make the call to Bedrock. Actually, what you have seen today is a call directly from the prompt from my console to Bedrock directly. You can do that. When we make the call via Python, we use the SDK, the Boto3, but you can do the same from your command line interface if you want. So it's not impossible to do this, but when you go beyond just making a call and into designing a solution, you will need Lambda, you will need any type of middle tier to add your business logic in. And I
So what
wanted you to see.
Mohammed's getting at is like you do not want to tightly couple your applications. Like you could technically do that, but then it's not flexible. It's very brittle. And so we're getting into this more loosely coupled, decoupled solutions. Also going to more of an event-driven design, which is very important within modern applications. So.
Thank you. Thank you for the explanation.
Is there more services that Bedrock can pair with? Well, Bedrock is provided to you, as I mentioned, it has multiple SDKs. So you can, if you have Python, if you're writing in Java or many others, you can do. So what we did today is when we chose Python, we added to the Lambda and make the call. But you're really free to use. If you let's say that you have an application running on your own VMs on EC2 instances, you can still provide the EC2 instance with attach the role and then make the call to the Lambda function. It's going to be called and give you the response back. So it's really your decision here. Are we crossing Java Python boundaries in this call? I'm not sure what you mean here. Can you explain this, please, Gopi?
Hi, can you hear me?
Yes.
Thanks for great presentation. Just wondering, some of these AWS infrastructure, the tech stack is primarily Java and stuff like that. So when you build a kind of a Bedrock API using Python, are there any boundaries that we need to be aware of?
I'm not sure of specific boundaries here. Maybe I need to look more into this. But again, at the end of the day, the SDKs available are calling the API, standard API. So if you can manage to build your solution in whatever the language that you are using is, and you can make the standard API calls, then you should be fine. But yeah, let me look at this. I'm not sure if there are any specific restrictions or boundaries for Java specifically. I'll need to look at that.
Gopi, like specifically like using the JPI stuff?
Right.
Yeah, okay. I don't think there's, I've not ran across the need for that
Yeah.
with Bedrock and Python.
Sure, thank you.
But then again, I mean, I just play around with making really weird chat box. So
Okay, there is a very, very good question here from Asana. I'm a business analyst, product owner. What would be my role as building GenAI apps are concerned? Well, it's a pivotal role actually because as a product owner or product manager, you decide on the features and what features can be done and when, and understanding the capabilities of GenAI and what it can provide or not gives you the opportunity to use these, decide how to use it and where and when in your application. So you cannot do this if you don't understand the capabilities or what this can provide you. It's not a silver bullet. It has its own use cases. So learning about the use cases for using the Bedrock and using these GenAI models is important for you, I believe.
100%.
Yep.
And I'm sure that for everybody that's the more experienced software engineers are more experienced, knowledgeable of the software development lifecycle. And now when we include AI into it, makes a better time for a software engineering team.
Yep.
Might be my bias there, though.
All right. Yeah, I think that's it, and we're not getting any more questions. I hope this was helpful, and let me know if this was something that you got good use of. If you want, we can have a follow-up, maybe Juan, on RAG. We can do 1 hour on RAG or something, if people are interested. I don't know if they can send you a message or something.
Oh, yes.
Just let us
If you guys
know.
are interested, message me. Like Meetup's going to open it up, so you could message me through Meetup. You all can also message me on LinkedIn. I am very responsive on LinkedIn,
Cool.
probably too responsive.
Yep.
But feel free, if that's something that you all are interested in, we could definitely do a session on RAG or anything else that you would like.
Yes.
And yes, the presentation will be available offline. I will put the link to the YouTube stream that it went to.
Excellent. And I shared on the chat, I shared the link app, I think, URL where you can get the resources as well. So yeah, cool.
Thank you all so much for coming. Have a wonderful, I guess, I don't know what time zone everybody's in, but evening or afternoon, depending on where you are. I'm in the evening, so if you're in the afternoon, today is going to be great. Okay.
All right. Thank you so much, everyone. I'm really happy to be with you here today, and I hope to see you again. Thank you, Juan, for the time.
Thank you. Bye.
Bye.